A very long time ago, the world was a different place. Imagine a time before cities, before farms, before even the simplest of written words. This was 3.7 million years ago. The lands of Africa were changing. Forests were shrinking. Vast grasslands were spreading. In this ancient world, a special kind of creature walked the earth. They were not modern humans, but they were part of our story. We call them Australopithecines. Australopithecus afarensis, a well-known fossil skeleton named Lucy, a crucial step in our family tree. Walking upright on two legs. No books, no diaries. They vanished long before history. Only the most durable parts remained. Scientists find bones turned to stone. They find fossilized footprints in wet volcanic ash. These are our only clues. From these silent remnants, we try to piece a lost story. The story is full of gaps and mysteries. One big question: their hearts and minds. Did these relatives help each other when in trouble? To understand if early humans helped each other, we must first picture their world. Life 3.7 million years ago was not easy. The environment in East Africa was a mosaic of woodlands and open savannas. The climate was generally warm, but it was also unpredictable. There were wet seasons and dry seasons. Finding a reliable source of water and food was a constant daily challenge. These early humans did not have large brains or complex tools. They were small in stature, adapted for walking on the ground and climbing in the trees, a useful skill for escaping danger or finding food and shelter. Their daily life balanced finding sustenance and avoiding peril. Their diet likely consisted of plants, fruits, nuts, seeds, roots, insects, small animals they could catch. They did not have powerful weapons for hunting large game. Their teeth show they were suited for grinding tough, fibrous plant material. Every meal was a result of effort, searching and gathering from the landscape. This constant need for food shaped their social structure and movements. They had to know their territory well. Danger was everywhere. The African savanna hosted a formidable array of predators: big cats, hyenas, crocodiles. A small, relatively slow hominin would have been a tempting target. Safety was not guaranteed. Every trip to the waterhole, every journey across an open plain was filled with risk. Survival depended on being alert, knowing how to react to threats, and perhaps on having other eyes and ears in a group. In this context, the idea of a group becomes very important. Living alone would have been incredibly difficult. A group offers safety in numbers, earlier predator detection, collective defense, and more efficient foraging. It is within this setting that helping each other becomes most relevant. A lone individual with a broken leg is almost certainly doomed, but with a group, that changes things. The most direct clues we have about the lives of early humans come from their fossilized bones. These bones are like pages from a book, written in a language we are still learning to read. They tell us about the size and shape of our ancestors, how they moved, what they ate. Sometimes they tell a more personal story of injury and survival. A bone is not just a static object, it's a record of a living process. When a bone breaks, the body immediately begins to repair it. Healing leaves a permanent mark, a callus of new bone growth. When paleontologists find a healed fossil bone, it opens a fascinating line of inquiry. A healed fracture means the individual did not die from the injury. They lived weeks, months, or even years afterward. Consider a broken leg. An Australopithecine with a broken leg would be unable to walk properly, keep up with the group, flee predators, or forage effectively. How could such an individual survive the long healing process? The survival of an injured individual is powerful, though indirect evidence. It strongly suggests the individual was not abandoned. It hints that others provided support, shared food, protection, help moving, or slowing group pace. The healed bone itself doesn't prove this, but it makes such scenarios plausible. We have several examples across early human relatives: a healed jaw, a healed arm or leg, each a testament to resilience. The question remains: purely individual toughness or the social fabric of a caring group? The bones alone encourage the question. So yeah, the clues are suggestive. Beyond bones, we have another extraordinary window into the past: fossilized footprints. At a site called Lake Toli in Tanzania, a remarkable discovery was made about 3.6 million years ago. A volcano erupted, blanketing the land in fine ash. Then rain turned it to soft mud. A variety of animals walked across it. Our ancestors did too. The sun baked the mud hard, and later ash preserved the tracks for millions of years. Today, they are a snapshot of a moment in time, a record of behavior frozen in stone. The most famous trail was left by at least 2, possibly 3 individuals walking side by side. The prints show they were fully bipedal, walking upright much like we do. Most compelling, they were walking together. Their paths are parallel and close. They moved in the same direction, at the same pace. This isn't proof of deep emotional bonds, but it is clear evidence of social behavior. They were not wandering alone. They moved as a cohesive unit. Walking together is the foundation of social life. A group that moves together can act together. Yet we must not over-interpret. The footprints show they walked together. They do not tell us why. Family, foraging party, safety in numbers. The tracks are silent. Let us look more closely at evidence from healed injuries. One compelling example comes from Dmanisi, Georgia, about 1.8 million years ago. An elderly male lost all but one tooth long before he died. His jawbone had completely resorbed, a lengthy process. He lived for years without chewing solid food. No blenders or modern processing. How did he survive? It is almost impossible without help. The old man of Dmanisi suggests companions processed food for him. Perhaps chewed it or pounded it to pulp. This is a direct, powerful argument for compassionate care. Though younger than 3.7 Ma, Dmanisi shows such behavior was possible with similar brain sizes. In Lucy's time, we find subtler hints: healed fractures on ribs, arms, ankles. A broken rib may be survivable alone, but a badly broken ankle could be fatal. Surviving weeks to stabilize would be a monumental challenge. Some did survive, hinting they were not left alone. Still, ambiguity remains. Bones can heal in many ways. Survival is not proof of care. Perhaps they hid near resources, hobbled slowly, or were tolerated without active help. Active provisioning versus passive tolerance is a huge difference, and nearly invisible in fossils. The healed bone is a mystery with multiple possible solutions. Well, that's where the real puzzle lies. The puzzle of group living. Living in a group seems a natural solution, but group life is its own complex puzzle, not just safety in numbers. It involves social dynamics, competition and cooperation. Looking to chimpanzees and bonobos, they form alliances, groom to reinforce bonds, share food at times, yet also fight, compete for mates, and struggle for dominance. Their social lives are mixed. It is reasonable to assume Australopithecines were similarly complex, likely in multi-male, multi-female groups where family ties mattered. A mother's bond with offspring is foundational and can extend to kin. Kin-based altruism is a powerful evolutionary force, yet resources like food, water, and safe sleep must be shared, leading to competition, dominance, and scarcity pressure. Would instinct to help win over self-preservation? Injured, valued family member, or dangerous burden? It might depend on circumstances. Grouping alone doesn't prove compassion. Groups could be loose, self-serving associations, but cooperation, sharing information, mobbing predators, caring for young and injured, yields immense benefits and could be favored by evolution. While the clues we have are tantalizing, we must be honest about their limits. The fossil record is incredibly sparse and fragmented. For every skeleton like Lucy, millions left no trace. We are peering through a small keyhole. Our evidence may be exceptional rather than typical. A single healed bone might be a lucky survivor. Lake Toli captures one moment, not the day before or after. We must resist grand narratives from few data points. Interpretation is hard. A cut could be a tool, a crocodile tooth, or hoof trampling. A healed bone shows survival, but not how. Scientists must test all explanations, not just the appealing ones. The idea of ancient care is beautiful, but we must avoid projecting modern values. Australopithecus afarensis had about 1/3 our brain size. Their cognitive and emotional world likely differed. They may have stayed near kin or tolerated weakness without our notion of compassion. Because of limits, scientists disagree. Some see cumulative evidence for early care, others stress ambiguity. Debate drives better evidence and sharper arguments. If Australopithecines helped each other, it wasn't hospitals. Help would be simple, practical, resource-based. The most fundamental form, sharing food. An injured forager would die without sustenance. A handful of berries, a nutritious root, a piece of scavenged meat, profound investments in another's well-being. Protection from predators, keep the injured at the center, maintain watch, raise alarms. Many species do this without large brains. Physical aid, support over rough ground, slow the group's pace, carry the young when sick, vital for cohesion. Simple comfort matters, grooming to remove parasites and reduce stress, resting close for warmth and security. Such small acts leave little fossil trace, yet they are the essence of social care, powerful forces for healing and survival. An unfinished story, what we know and what we don't. So, did our ancient ancestors, walking the plains of Africa 3.7 million years ago, save each other? The question remains open. We have not found a definitive answer, but we now see them as complex social beings who face danger together. What we know, Australopithecus afarensis lived in groups. Laetoli proves coordinated movement. Some individuals survived grievous injuries. Healed bones attest to survival. Primate relatives show social support, grooming, and food sharing are deep in our lineage. It is plausible our ancestors shared them in some form. Unknowns persist. Healed bones don't prove provisioning or protection. Laetoli groups might be family or loose aggregations. Their emotions are inaccessible. The honest answer is, maybe. Evidence leans toward rudimentary care, not yet conclusive. As methods advance, a missing piece may turn possibility into certainty. Until then, we keep asking, looking into the deep past for a reflection of our own humanity.